Hi all you science lovers, it's Miss Bulky here, and today I'm going to do a demo on conduction. So what I've done here is I have a knife, and it's a metal with a plastic handle. It's a solid, so we're dealing with conduction because, as we know from learning before, if it's flowing particles, it deals with convection. So I have taken 4 nails and I have put wax, solidified wax onto them so they are in a row, okay? What I'm gonna do is I'm gonna heat up one end of the knife and we're gonna see what happens to these nails. So as I'm heating up the knife at one end, I want you to take a prediction of what you think might happen to the nails. Let's just move it this way so I have a larger surface area. I don't have the best. There we go. That might be better. Okay, so this may take a little bit. I'll pause it. Okay, so as you can see, oh, there goes one of them. One of the nails that's closest to the heat has fallen off, okay? So what's going on here is that I have a heat source that is heating up the particles in the metal. And as the particles are heating up, they are starting to gain more kinetic energy. So when so how thermal energy works in conduction is that a hot particle will give some of its energy to a colder one. So this one is the first one that fell off. What do you think will be the next one to fall off? So we're seeing it should be, as it goes through, it should be the next one should start to come off, because what's going on is that the hot particle is passing it on to the colder ones and it will start to go through the chain. So let's see if that, so the first one definitely came off. It looks like this second one is starting to melt a bit further. This one doesn't look like anything's happening. And if I continue to let this go, it eventually what will happen is each of these will fall off in succession. My handle, though, will, oh, there goes the other one, yay! So my handle will end up not gaining very much heat because it is a poor conductor, meaning that it cannot, it does not get heat as easily as a metal does. So as you can see, the first one came off. I'm heating it up here and it starts to make its way down. So this, if I continued with this, it would continue with the next one and then the next one. So what's going on here, just to show you what's happening to our particles, is here we have our heat source, okay, and it's heating up the particles. So these now are, the red is representing that they're getting hotter, okay? So they are then transferring their heat, continuing down the line. So they're getting faster, gaining that kinetic energy, which is getting that thermal energy, heating it up as it carries on down, and then it will continue to make its way down. The reason that the metal is doing very well at getting the heat, transferring the heat, is because it is a very good conductor. So metals like copper and brass, those are usually used in cooking ware, and steel, aluminum, because when we have things that we want to heat up, like a kettle or a pan, you want it to be a metal because it heats up faster. The handle, though, would not get hot, and the reason is because it is a poor conductor of heat. It does not transfer heat very well. The metal does it a lot easier. So that's a little demo on conduction using our solid, and hopefully you learned something fabulous.